packets of information. Before we move to this new topic, first let's do a quick recap. So you all know that internet is all about sending digital information. It's about getting binary information from one computer and sending it to the other computer. And these computers have to be on the same network. They need to be connected on the same network. So how do computers find each other to send this information? How a simple emoji on one computer gets sent across from another computer from another location and connected to the network. How does this happen? So for this, we have some addresses for every computer on the internet. You can see an emoji over here. It gets transmitted to a network from other computer, and this all happens in binary data. And how does this happen? For that, we have addresses for every computer on the internet. These addresses that we have are unique addresses. They are known as IP addresses or protocol addresses. Originally, we had only IPv4. We had four number sets, and these number sets were separated by decimal points. The range of each number would be from 0 to 255. So what I'm trying to explain over here is, so this is one set of numbers, this is another set of numbers, this is another. So IPv4 represented four sets, and how they were separated through a decimal number. And what the range of this particular set can go from, it can go from 0 to 255. So this was IPv4. And it turned out that this number combinations were not enough. So we started upgrading the system to IPv6, which actually has 32 different hexadecimal digits and letters that provided way more combinations. So now every device on the internet has unique IP address, and that's how two computers find each other. So how IPv6 is different? This has 32 different hexadecimal characters. So it's like 8 sets. Each set is of 4 hexadecimal characters, 1, 2, 3, 4, 5, 6, 7, 8, and each has 4. So it's 32 characters, and these are hexadecimal. Hexadecimal means combination of your letters and numbers. So this is what IPv6 was. And this provided unique IP addresses and many more combinations for each computer on the network. Now the problem comes is that no one wants to remember the IP addresses. That's where the DNS comes in. That is the domain name systems. What DNS does is it associates the human readable website address. It associates the human readable website addresses, the website domain names, with an IP address. So it maps a unique IP address to each of the website on the internet. For example, if we take a few websites, for instance, google.com, wikipedia.com, or amazon.com. So this might be the IP address of google.com. This might be the IP address of wikipedia.com. And similarly, this might be the IP address of amazon.com. So this is what DNS does for us. It associates an IP address for website. So every domain, the name of the website, every domain has a unique IP address associated with it. So this IP address is unique. If this is the IP address of Google, then no other website can have this address. This is like the unique home address for the website. Now we understood DNS, we understood IP address. Now how the structure of internet looks like. When the information is sent, how does it get across the network? This is where routing comes in. So what is routing? Routing is just a massive networks on the internet which are connecting small subnetworks. So these are intermediary devices connecting small subnetworks together. So we understood internet is just massive network of various routers, each of which are connected to few other routers. So remember, not every router is connected to each other router. This router is not connected to these two. It is only connected to this one, and this one. This router is not connected to this one. So routers are connected to few other routers. So if we want to get information all the way from one computer on the left to another computer on the right, if we want to take information from here to here, what would be the way? The information will hop between many routes on the way. So it will hop through this way. It can go through some another way also. If this was one way, another way could be following this route, this one, and then going from here. So it can hop through multiple routes. So this is nice because we have several different paths to same destination. That way, if one route's break, then that's fine. We can reroute through some different path. So for instance, if this route gets broken, so if this router crashes and this route is no more available, we have the other route as well. So the connection would be established following this route. So that's how the combination of routers helps us and provide us uninterrupted flow of internet, uninterrupted flow of services over internet. If one router crashes, there are multiple paths for information to be traveled. This is also scalable because now we can add or remove routers when and where it is needed. Suppose this router crashed and we need to remove it in order to replace it, the internet would not stop. There are multiple pathways to it. So we can replace it as well. So now we know how information goes from point A to point B. Now, what exactly does information look like? What is being sent? We are sending information through this route, but what is going from here? How information looks? How exactly our data gets modified as per the stated rules, as per the stated protocols? This is where the new topic that we are going to study comes in. That is called packets. So what are packets? So packets in plain English, we can say these are small quantities of something bigger. For instance, if I have a bigger piece of cake and I want to put it in small boxes, I can cut this cake into multiple pieces and I can put each cake piece into this particular box, this one into this. So this becomes a packet of cake, a small quantity of cake from a bigger piece. This was the bigger piece, the entire cake. So this is definition in plain English. So all data, remember, all data over the internet is broken down into several tiny units. These tiny units are called packets. These are small units of information sent over internet. So all data, just remember, all data is sent over internet in broken down tiny units of packets. Okay, so let's move ahead. So if we have to define packets, these are the data broken down into tiny units, and this units of information is sent over internet. So let's understand with an example. Suppose you think of buying a nice chair online. You sit on your laptop, you open some e-commerce website, and you start searching for nice chair. You decided which chair to buy. You put a specific chair in your online cart, make the payment, and the chair company delivers the package at your doorstep. Now your work of buying the chair was done. You sent a request to the company, please send me this chair. Okay. Now, after making the payment, you have fulfilled their protocol, their rule. You make the payment, we will deliver you. So it is one of the protocols between customer and the seller. So now what happens? You receive a box instead of a complete product you ordered. At your doorstep, you were thinking you would get a chair, but you received a box. Now, when you open the box, you see that it is filled with all parts of chair. You were expecting a full chair, but you received different parts of chair. You take out the parts and now you're confused. Why? You're trying to figure out which part needs to be assembled first, which part needs to be assembled later, what should be the order, and so on. To make it easy, the package comes with a manual. This manual states unique numbers to each part. You can see each part is being numbered uniquely. Every part of chair gets a number. Why is this numbering done? This numbering is done to make sure that whenever some information or some data is provided in form of tiny units, at the time of reassembling, they can be arranged in specific order. They can be reassembled in a specific order, in the right order. So you follow the manual, you follow the instructions, and you assemble the parts into desired product. So when you follow all the instructions and you arrange the pieces according to the numbers mentioned on the manual, you get the desired product. So now here, with this analogy, what are we trying to understand? Here, each part of chair is the packet containing information on the internet. So each part of chair is the packet, is a small packet containing information about the chair, information about the data that is being sent, right? Now, there is now with each part within each packet, there is list of instructions attached that makes it easier for any user to reassemble the data and finally reach to the destination. This manual is pre-provided by the sender of data, by the company, so that you can reassemble the parts and make the desired product. So this is how a general example would look like when we're trying to understand what packets are. How a bigger product, the desired product, is first broken down into tiny units, transmitted over certain media, contains a manual. That manual would have all the instructions how to reassemble the data and in which order. Two major points this manual tells: how to reassemble and in what particular order each part would come. And if we follow all these instructions, we get the desired product. So the major point you need to remember, what are packets? Tiny units. It's tiny units of data that are transmitted over internet. Simple. So let's understand in terms of web world. Now we know that all data is broken into tiny unit called packets. Let's see how it works on the internet. So remember, all data on the internet, all data is broken down into tiny smaller units called packets. For instance, this is the data. It is broken down into tiny small units. We are going to see with a very wonderful example. Suppose if a user wants to send an image of a lion across internet, you want to send this image to your friend, an image of lion, and you want to send it across the internet. Now the picture, the picture of this lion would actually get broken down into several different pieces. So each piece is called a packet. Each of these pieces would get inside its own packet, and those packets would be sent across the network routed through internet. So just see what's happening over here. I'll quickly review. This was the final product that we wanted the other person to receive. If there is my friend at some other computer, I want him, and I'm sitting over here, I'm sending this product, this image, to my friend. Now I want my friend to receive the image in same way, but during the process of transmission, what happens, the image gets broken into tiny pieces, into small packets, and each packet gets its own kind of you can see each piece gets its own packet. Now each packet would be sent across network routed through internet. These packets need to be labeled with metadata. Now what's metadata? Metadata is a simple information about package. The basic information, what each packet contains. What each packet contains, that's the basic information. Now, it would include the to address. This to address is the IP address of the receiver at the other end, to whom we are sending this packet, to whom. From is the one who is sending the packet, and what is the size of data inside. So what each packet would contain? It would contain the actual data. This is the actual data. By size, we mean the actual image, the address of the sender who has sent this particular packet, and to whom this packet is being sent. And by term address, I mean the IP addresses. So why is it important? Because if router receives a packet, it needs to know where it is going. You can see that if this is a router, we assume, and this is one system connected to another system over here, router needs to know from where the packet of information is coming and to whom that router has to forward the information. Because there are millions of routers across the globe and they are interconnected. To get the right path, they need to know from where the packet is being received and to whom it has to be sent. So that's why we mention the from addresses, the to addresses, and so on. So moving ahead, once these packets arrive at their final destination, they are pieced back together. Once they arrive at the final destination, they are again joined back together, and then we have the final picture of the line. So this is how a normal image or a text or any number or any video or anything travels across the internet. Moving further, the layout of these packets, how these packets, the information should be provided, this information, the layout of these packets, how and what information should be provided, that comes under a certain protocol. Which protocol is that? That is your internet protocol. I'll repeat myself. The layout of packets is defined by a protocol. All computers on the internet, all devices need to agree to set up their packets in a same way so that they can communicate on either end and can understand what's inside. So what I'm trying to say is, if this is a system and this is another system, they are connected over here. They need to understand, if I'm sending some information, a packet, suppose a packet of information, and this particular device is receiving it, this packet is having some very technical information. If both these devices are following same rules, then this device can decrypt this message, can understand what this packet means, because if this device is acting as a sender for some other device, let's say there's another device, when this device sends some packet, it follows the same protocols and this device understands. So all devices connected on network are following the same protocol. That's why they are able to understand what information is being sent and what they are receiving. So the protocol is called internet protocol, right? This is your internet protocol. So what internet protocol actually is, it not only assigns the addresses to every computer, it also defines the layout of packet. So I would say it standardizes the layout of all packets. So what IP does for us, first thing that we understood, provides the addresses. Provides IP addresses, unique addresses to each computer, each device. Second, it standardizes the layout of all packets. What an information packet should contain, that is defined by the IP, your internet protocol. And now each packet must contain some information. What each packet must have? Number one, destination's IP address, to whom we are sending. Number one, from where the information is coming, that IP address, and the actual data being sent. So if this is the packet of information, and I'll just repeat, what is packet? Tiny units of data. If this is my image and my image is broken into 4 parts, then each part will be placed inside a packet along with other information. What is the other information? An IP address and of the destination, and IP address of the sender, to whom we are sending. So this is what a packet looks like. Now we have senders and receivers' actual address as well as the data. If we are considering only IP address working between two computers, we can send only single packet of data. Why? So suppose there are two computers over here, and we are trying to send one image. This is an image of, let's say, a mountain. This is a mountain and a sun over here. Now, as per the internet, it would be divided into 4 parts. Now, if these 4 parts are over here and we are connected only through IP protocol, then the IP is not providing which part should come first, what is the number of each part, and how this needs to be reassembled. Suppose we are receiving one part over here, one part like this and this. But when we transmitted the data, we only received 2 parts. The other computer is now not able to judge which part is missing and from where that part can be resourced back. So if we are considering only the IP protocol, then this image needs to be sent as one single packet only. It needs to be sent by this way only. It cannot get divided. So because there is no tracking system, if we are dividing an image, how we can track multiple packets, how we can resource back if some packets are missing, how we need to reassemble them. So this was not taken care of in the IP protocol. So what happens if we want to send multiple packets? Because on internet, we are sending multiple packets every second in gigabytes and at such a high rate. So for this, we need another protocol. That protocol is called your transmission control protocol. So remember the IP. If we are using only IP, then two computers on a network can send only single packet. Why? Because they have no system to track multiple packets. They have no system to rearrange multiple packets in right order. So we'll understand with this example. We are moving to transmission control protocol, which overcomes this drawback. So with TCP, we actually add one more thing, which is the packet number. So let me show you an example. So what TCP does is it allows us to send multiple packets between two computers, and it checks if all packets have arrived at the destination. It helps in assembly of packets in right order. So number one, what TCP does is the information can be divided now in multiple packets. Number two, it checks that all packets, if there's 1, 2, 3, 4, and 4, 8, and 12. So it checks if all 12 packets have received or not. If we have received 10 packets, then it has a system to track down 2 packets and bring them back. So it helps in assembling the packets in right order. If this was the image, the same image should be formed when packets are reassembled back together. So we'll see with the same example that we were doing with an image of lion. So now earlier the packets are labeled with metadata. This is metadata, and according to IP protocol, this information must be there because IP standardizes the layout of your packet information. So IP does this. Now what TCP adds on, TCP adds the package number. So TCP adds on a packet number to this. So just have a look at what different does this bring to our whole structure. So now we can say that, okay, this particular image should come first. This package should come at second number, this can come at third, and this can come at fourth. So TCP adds a packet number to each packet, and that way we can track what order they are supposed to come in. Now, when we are sending an information across internet, we are almost using always TCP and IP together. That's why these are called TCP IP protocol. This is written like this, and they're called TCP IP packets. So we're using TCP and IP together always on the internet. So we call it as TCP IP, TCP IP packets, TCP IP protocol. So now packets are labeled with number. Once they arrive, even if they are out of order, it's okay. We have the numbers. We know how to put them back together because with the proper order number, we can track them down. So for instance, if this was we sent an information and we received packet number 2 first, then third, and then first, and then number 4. Now TCP can track these numbers and can rearrange them in right order. It can rearrange back to 1, 2, 3, 4, and then it can process the reassembling. So it's also useful because let's say one of the packets doesn't arrive at the destination address. So for instance, it doesn't arrive at the destination address. Let's say one of the router crashes through and the packet that was traveling through the route, that packet doesn't make it. That the packet is not able to come to our destination address. Now, due to packet numbers, we get to know that which packet is missing. So right now we have 1, 2, and 4. So TCP knows, okay, I've not received number 3. It can track that down. I've not received number 3 information. So what TCP will do, TCP will re-request the missing packet. TCP will ask the router, ask the sender again to send me only the third packet, not the entire information. It will ask to re-request the missing packet. Once the packet arrives, we have their numbers, we know how to put them back together, and joining all numbers in right order, the final information is delivered. So now even the packet number 3 was re-requested, that came back, and we have all the information together to bring it back to the original picture. So that's how TCP is working on a broader view. So let's quickly recap what TCP and IP does. So TCP and IP define metadata about information being sent. So what IP does, it tells to add the address of the sender, add the address of the receiver. So this is the sender's address from where we are getting. So this is your receiver's address. This one, to whom we are sending. The size of image. By the size, we means the actual data. That part of image. This was the image part, right? And we have 4 parts divided. So the actual data, the image. So that if we have that, we can calculate the size of image as well. And what TCP adds on to this structure is the order number of each packet. With the help of order number, all the packets can be tracked. If some packets are missing, then the TCP re-requests back and asks for those packets. So for instance, if we consider a very generic example, when you're watching some YouTube video and sometimes you experience that your video starts buffering in between, constantly you're missing some information, or the audio and video are not syncing together. At that point of time, some packets information is not able to reach you at right time. And TCP constantly re-requests and asks for those packets. Once that packet is received, the buffering stops and you're able to view the video once again. So this is one example when we are watching a video and we experience some buffering. So understand at that point of time, certain packets are not able to reach to your end at a particular time. See, TCP is trying to get those packets for you. So that's what happens. So now we know how we get packets across the internet. But what exactly are we sending in these packets? We have still not understood that what exactly are we sending? We are sending this information, but how this information looks like inside a packet. So we would understand this with the help of your HTTP protocol. This is where your HTTP comes in. So what is HTTP? It is a protocol that standardizes the language for talking to web servers and receiving web resources. So what are web servers? The servers where the websites are hosted. And what are web resources? Your HTML files, your CSS files, your JavaScript files that cumulatively will result to the beautiful web page. So these are the web resources. So HTTP standardizes the language between the user. If this is the user, and this is the server, how they will communicate, this language is standardizes by HTTP. So if this particular user is following HTTP, this particular server is following HTTP, both can understand each other. And when this server is sending the web resources, the user can understand what type of resource they have received and how to decode them and show the web page. So I would say it's a system protocol for all computers. It establishes a common language for requesting and receiving web resources. Now, HTTP is Hypertext Transfer Protocol. It's Hypertext Transfer Protocol. What is hypertext? Your HTML. You have heard about HTML, the hypertext markup language. The hypertext documents within this is the language in which web pages are written. So web pages are written in hypertext markup language. To receive the hypertext information, HTTPs were introduced. They define how computers would request and receive web pages. So we have constantly been talking about request and responses, but we have never seen what a request looks like, what a response looks like. So Shakib is asking, what is the size of packet? So size depends on the type of data you are transferring, how many pieces your data has been divided into. If you're sending one image, the size would be bigger. If that image has been divided into 10 parts, each size could be 1/10 of the image. If you're sending a video, size could be bigger. But if the video has been divided into multiple parts, then each unit would have an individual size depending upon the amount of data it is holding. So size is not fixed. It depends on type of data and how many packets that data has been divided into. So now I was talking about what is a request and response? How does it actually look like? So we're going to see what an actual response looks like, what an actual request looks like. Okay, so every time you're asking any information on web page, either it's text, image, video, or anything you're trying to access on the internet, there is an HTTP request and an HTTP response. So if you want to visit Amazon.com, then your computer isn't really saying to the Amazon that, hey server, can you send me Amazon.com homepage? So if we want to visit this Amazon server, our computer is not talking in this language that, hey, like the way we communicate, the computers do not communicate that way. They do not communicate in plain English. They do not say directly to Amazon server, provide me this web page. They construct a message. They construct a message defined by HTTP protocol. So remember, if computer wants to access a server on the internet, they construct a message, and that message is defined by HTTP protocol. And that message defined under HTTP protocol is called an HTTP request. This is what it looks like. An HTTP request would have many information in it, but some of the major information it would contain is these informations. What are these information? The first, if we try to understand this a little bit more, the first line says what resource you are requesting. So I'm requesting the home page. I'm requesting the home page of a particular website. Okay. Just a moment. Yeah. So I'm trying to access the particular home page of this website. So this one, right? So what resource are you trying to access? First line is trying to tell you that. So there are other information in this also, like this is the get. This is one of the request methods. The get method tells me that I want to get this website. There are other methods as well, like put or post. So we would be discussing in the backend section. But right now, just try to understand what a request is trying to tell us. The request states what resource I'm trying to access, what version of HTTP I'm using, what type of website I'm trying to access, where I'm trying to go, which website I'm targeting. The resource lies in this particular host. The content type of my web page, the content language, and so on. So once the request reaches the Amazon server, the server program will accept this HTTP request as input. It will be able to parse this information. Amazon server would be able to read this information and get the proper information out of it. That happens because servers are following same set of rules under HTTP protocol. So let me show you how HTTP request looks like on an actual web page. Let me pull up the web browser. So let's see this. So let's say I want to go to wikipedia.com. So now how to check the request? Open your web developer tools. There is a tab by the name of network. You can see the network over here. So now you can see nothing over here, but if I'll just reload it, I'll just expand it a little bit more. Yeah. If I just reload it, see what all is happening. So many things are happening over here. And now these are all the requests being made, and one after the other, these responses were received. So if I click any one of them, so if I click this one, this is what request is providing us information. What is the URL I'm targeting? Which method I'm using? What is the status code? What a remote address, and so on. So status codes are just like messages from server. They tell us what result came out of the request being sent by the sender, by the client. So for instance, there are multiple status codes. It could be it ranges from your 1 to 5. So there are 3 digits. So like this is 304. So it's like 100, 101, and so on. So there are multiple status codes. Some of the important status codes are like your status code number 200. So 200 is a very important status code. It tells us that the web page was rendered successfully. Nothing went wrong. Your status code 404, it tells us that something went wrong, page could not be found. So status codes tells us what response, what is the message from server regarding the request received and response sent. So this is what actual request looks like under the hood. There are much more information, but this is what actual request would hold. If you go down, you can see the request headers and so many other information as well over here. So this is a general example. And similarly, the response over here, we would be coming to response. So let's move on to our slide. So what happens now is any HTTP package, whatever packages we are getting are converted to this requests. These are different packages being constructed and they are converted to these requests. And these requests travel across the network to reach a particular server. And from where they are getting the information of the server from this particular line. The host already consists the address to whom the data is being sent. We started this in the previous slide that a package would contain 4 major informations: to whom the data is being sent, from where the data is being sent, the size of actual data, and the packet number. So each package is composed as a request message. Request message is the HTTP request, and that contains all that information. From there, the internet knows to whom I have to deliver this particular package. So now once this is done, it will find inside the server. Now it would go inside the server. And now server will try to search, okay, am I able to find information out of it? And if the server is able to find the information, it would say, okay, I have the hypertext files that you're requesting. I can send you that. Now our server also cannot communicate in plain English. All the information that our server wants to respond back, that needs to be sent as an HTTP message. And any message that is being sent by server to the client is considered as an HTTP response. So it might look like this. So this is an HTTP response, and this is an HTTP file that is being sent. So if we move ahead, so this is a particular HTTP response. So this, you can say these are the status codes. These are your version of HTTP. This is 1.1. Now we are using HTTP 2 as well. There are multiple benefits of HTTP 2. So this OK tells the message of this particular status code. Okay, nothing went wrong. This is the name of server from which the request has been sent as a response. What is the content type? It is HTML. What is the language being used? That is English. So to write this request in terms of words, the server has used the English language, right? So this message is sent as a response. So let's put all of this that we have studied so far. What TCP, IP, DNS routing does, they all work together to send packets over internet. So remember, they are only sending packets over internet. They are not providing any information in the packet. They are telling what information should be there. They are telling what information should be there, and they're sending over internet, over the internet. Routing, we know that multiple routers are connected from client to server and information travels. DNS, we know that it provides us the IP address of a particular website. TCP IP provides various information, breaks the data into small packets, and tells that each package must contain certain metadata, like the address of sender, receiver, size, and your package number. So, and what HTTP does, HTTP makes sure that information inside the packets can be understood. It structures the request and response we are sending. These request and response is inside several different packets. So every package has the request message associated with it. every package. And once they go once they're delivered to the destination, they are pieced back together, and then we see the actual image. So I know this could be a way lot information right now to dive in, but this is how everything is working together. It would be very easy now to understand when we'll start our story of how everything is working together from scratch. Like when you visit your website, when you visit a web page and you enter something, how everything happens. When you go on a computer, you access a web page, what exactly happens from start to finish. Let's see all of that working together step by step. First step, you enter the URL into the browser, or you may also click some of the hyperlinks that precede you to the browser. So what do I mean by that? For instance, if I go back to this page and if I open a tab, now I have not entered anything over here, nothing. But if I click of this, these are hyperlinks. If I click this, this would take me to a URL. This is taking me to a URL. I'm not entering anything. These are all hyperlinks. So you can either enter a you can either enter a URL, or you can click on some hyperlink that is taking you to URL. So what is URL? It means that you're trying to locate a resource that exists somewhere on the internet. And where does this exist? Where this resource exists? It exists in the domain. So domain is the place where you need to look for the resource. And after domain, we have path. So this is the domain. This is where the resource lies. And this is the path. This is the path. This is the resource that we are looking for. So remember, this entire thing is the URL. The name of website, the name of company that you see is the domain. And it states where the resource lies. And the information after .com that you enter is usually the path, and it is the resource that we are trying to access. We're trying to access the home page of Amazon.com. So in this case, we are requesting the home page of Amazon.com website. Now, step 2, this was step 1. We enter the URL. Step 2, creating HTTP request. From this URL, your computer will construct an HTTP request. The computer will direct the request to the host website, that is Amazon.com. So in request, I'm asking for the home page. I'm trying to access the Amazon servers. I'm specifying what kind of data I'm looking back and what kind of information I'm representing in which language, that is English over here. So a request is directed to host website and content type and language are specified. So these are part of request. The entire layout is defined by HTTP protocol. Remember, the entire layout of a request is defined by the HTTP protocol. How a request would look like, it is set by HTTP protocol. Now the problem is, where is exactly the Amazon.com lies? I do not know. I do not have the IP address so far. To get the IP address, the DNS comes in, domain name system comes in. We will cover this domain name system right now in very easily. So what happens? DNS is a team of 4 servers. So these are 4 servers. And remember, this .com is called top level domain. Top level domain. And this Amazon is called domain. And this entire thing is your URL. So let's see what happens now. The resolver that is over here will catch the website address. It is not doing anything. It is just catching the website address. It checks if it has stored the IP address in its memory. In cached memory, does the resolver has the IP address? If not, it would reach out to the root server. Root server will see if that server has the IP address or not. If that root server does not have, it will check what top level domain is associated with the IP address. According to the top level domain, it would go to the specific top level domain. So here, it could be multiple servers inside, like .org servers, .com servers, .in servers, .dev servers, so many more. So the root server will check the top level domain and go to the right top level domain server. The top level domain server will further have multiple servers inside as per the different website addresses. So it will start tracking which particular server holds the Amazon name inside it. Once it finds the Amazon name over here, suppose over here, that particular is called the authoritative server, and this server will provide you the IP address. So first, resolver will catch the website address, checks with the root server if it has the address or not. If not, root server will check the top level domain, take it to the concerned top level domain server, and under that, they will track which server has the Amazon name stored in them. And when they find it, it will provide the IP address, and this IP address will be routed back to the client. And then the journey from client to the Amazon server would start, because now we have the address to whom this website, to whom we are targeting to. So let's say we got the IP address as 2.2.2.2. The IP address that we received, it's just a dummy address for the Amazon. By following this process is 2.2.2. We would be keeping this IP address as for our reference. Now we have the request ready in right format. We have the IP address of website. Now what we are looking for. After that, TCP and IP will break the request into several tiny parts. Now your request to access a particular web page is broken down into several tiny parts, and it tells to whom I'm trying to access, from where am I coming. This is the IP address of this PC. What is the size of each packet, and what is the number of a particular packet. So this is how the packets get generated. Now each of these packets will separately be sent over the internet. So each of this packet is sent separately over the internet. So it might happen that some of the packets do not come. So for instance, over here, we received number 1 and number 3, we did not receive number 2. So what would happen in this case? So what would happen in this case? The TCP will start rerouting, will start asking for the missing packet. TCP will track down and will ask that send me the packet which is missing. So what TCP is doing for us, it is checking that every package has made it to the end. And if not, it will re-request the server to send, it will re-request to the sender to send me that particular packet. And once the TCP makes a request and sender receives the packet, we are again having all the packets with us. So let's say it gets back. Now we have all the packets 1, 2, and 3. Now we know that our servers follow the same protocols. So they are able to understand the HTTP requests. So after that, the server will unpackage them and piece them together to able to read the request. So this is the request. Earlier, server received this package information. The server is trying to reassemble them in right order and trying to read the information. Once it reassembles it, it gets back to the request. This is the request that server is trying to read. Okay, so now the server has read the request. After understanding the request, the server creates the HTTP response. The response will have the status code, the server name, content type, and other important information. And HTML files are also included in this response. Your response contains the actual data also with it. All of this is packed as an HTTP response. That's then get broken down into multiple packets and then sent back to the device who initiated the request. So same here, if something is not being properly sent, the TCP will reroute and will ask for the server to send me the missing parts of the information. So what changed over here? Just see, the address to whom we are sending has changed. Earlier we were sending to the server. Now we are sending to this particular laptop. And from where is it coming? It is coming from the particular server size and number. So if these two addresses are there, then only TCP is able to make sure that to whom it can ask for the missing part, from where it can ask from the missing part, and once it has received the missing part, where it has to send that missing part. So the protocol repeats, the packets are sent over internet and following different routes. Some of them might make it, some of them might not make it. TCP will track it through the missing packet number and initiate a re-request for missing packet, and it receives the packet. Once all the packets reach to the computer unpackages them and pieces back all the packets and reads the response received. So our computer receives it and TCP provides all the packets. Now we have all the information. It is repackaged, it is unpacked, and again, we've received the response at the client's end. Now client is able to understand the response. It provides that response to the browsers. Our response was containing the HTML file that is provided to the browsers, and that browsers then re-render that particular HTML page into Amazon website. So this is how entire process is working. So let me pull up another screen to show you visual that how user is entering and how the web address is traveling. Let me pull up that screen for you real quick.
Excuse me, Rahul, yeah. I have a quick question for you.
Yes,
regarding
please.
The packet, is there any specific reason behind that? Behind the broken, I mean, the data that broken into several packets. So while they are carrying, I mean, same size of the file.
So whenever any file is broken down, the package is not the same size of the original file. It is always lesser size. So why we are breaking down a particular data into packages, so that small bits of data, tiny bits of data can travel faster and reach through different routes. So if I show you a particular image, allow me just one moment. Let me pull up that image for you. Okay. So just see this image, for instance. Now we have a particular data being divided into 3 packets, right? Now each packet can travel through different route. One can go from here to here. The other can go from here to here. Some other routes, because the other can go from here. Through different routes it can go. You're able to understand this, that each packet can travel through different route so that they can reach faster to the client, and then the client device can reassemble them and read it. So if what happens is, now suppose this particular we can say this particular router gets broken. If there is single piece of data and that is traveling from here to here and not able to reach, then entire data has to be re-requested through some other route. And if we are using only packets, then supposedly these 2 packets have reached, then only a small part of packet is needed from a particular server. So you must have seen at some web pages, suppose this is a web page, and sometimes the header is not visible, but some images are visible, or some text takes longer to reach than the images. So if you open a web page or you open a YouTube website, some videos do not reach you directly, but few videos reach you. So that provides easy access to user so that they can start with the website, meantime the other resources come in. But if we are not breaking down the data, the entire data has to be rendered at once. We cannot render different packets. So so it makes it easier, it makes it faster, and if something crashes down at the level of router, then other parts can reach down to the user to give initiating experience, and then meanwhile the missing parts are re-requested back from these source.
Got it, Rahul. Thank you so much.
You're welcome.
That was pretty clear.
So allow me just one moment. Okay. So all of you are able to view this page, right? The paths of internet and everything, right? Just give me a yes.
Yes.
Perfect. So what's happening over here? We have a user wants to visit Wikipedia page. User enters the browser, enters the website over here, and the data travels to internet. But that's not actually happening. What all is happening, let's see. So let's clear all of this, all the information and everything, and keep only the major things. So user wants to visit and search for computers. So over here, if you see, this is your URL, this is your path, and this is your domain. This is domain. This is your path. User wants to access this page at this particular place, right? So now this has three paths: your HTTP protocol, domain, and resource. So what happens first? Now I need to get the IP address for this website first. The first thing that will happen is this particular website would go to DNS server. This is the first step. This is called DNS lookup. DNS will start searching into its 4 servers and try to find out that if particular DNS server has the IP address of the domain, the IP address of the domain that particular user is trying to access. Okay, so this is the first step, the DNS lookup. The next step happens is I've got the IP address. Now the IP address, let's say this is the IP address for me. So if this is the IP address, I'll move ahead and DNS converts URL into real addresses. So instead of website, now earlier it was Wikipedia, now DNS has provided the browser website. Till now, we have not contacted the web server of Wikipedia. We are still getting in touch with the DNS server. Once we've received the website, the IP address has information as well. So IP address, this is the IP address, and this is the port number. Usually the port number 80 is for your HTTP and 443 is for HTTPS. So next step, what happens is your TCP IP connection builds up. You've received the IP address. Now the TCP IP connection would build up. And then the request would be formulated and request would be sent. And once the server receives the request, it unpackages the data, reads the request, and then unpackages the response. The response then is being sent through data in form of different packets. Once it reaches the browser, our response has the data files also. So these files are then rendered back as your web page. So this is how generally things are happening. So in between, first DNS server works. Then once receiving the IP address, the information is broken down into packets. That information is sent as request. And then on receiving the request, the server formulates it, collects the resources, makes them into packets, and send them as the HTTP response. The response contains the data files, and those data files are then rendered back to the browser, and browser shows us the web page. So this is a very easy to understand overview. I have a nice video regarding it. It would make things more clear. So let me show you that. Let me pull up that video. Okay. I'll just play slightly and do let me know if you're able to hear the sound first. Okay.
Welcome to data flow on the.
So is everyone able to hear the sound? Perfect. I'll just play this. It's all about how data is traveling across the internet. Everything that we have studied today, this video is describing that. So do watch it very carefully. Many things it would clear all your doubts regarding what is happening across internet when the data is flowing.
The internet. The internet is a worldwide collection of computers that are linked together. These global connections form a common wide area network, also known as the World Wide Web. This global connection allows you to exchange information with someone down the street or halfway around the world at any time of day, 365 days a year. Let's look at what happens when you press the Enter key on your computer and send information out to the World Wide Web. The information you send is broken into smaller pieces called data packets. This allows people around the world to use the internet at the same time. Your information is sent through the internet as small data packets and reassembled at the receiver's computer. Let's compare how data flows on the internet to how cars travel on streets. The data packets from your computer are sent to your Internet Service Provider, or ISP, which sends them out to the internet. Just as streets have speed limits for cars, the speed at which your data packets travel is dependent on your internet connection. High-speed connections like DSL, wireless, and mobile broadband allow data packets to travel at faster speeds than slower connections like dial-up and older broadband. The speed at which your data packets travel is also dependent on the size of the data packets. Just like large trucks take longer to get up to speed and may travel at a slower speed, larger data packets travel more slowly and take longer to reach their destination. Each data packet contains a piece of your original information, as well as your IP address and the address for the destination computer. It may also contain a sequence number if the application you use to send the information is guaranteeing its delivery. The data packets may also contain other bits of information needed for controlling and checking their content. Just like cars may use different roads within a highway network to reach the same destination city, your data packets may use different routes within the internet network to reach the same destination computer. In this example, all of the red cars have the same IP address. This means the cars have the same origin and destination. They are, however, all traveling on different paths to reach that destination. The Internet is a series of many interconnecting networks. To help manage traffic on your local roads, a traffic cop directs and monitors traffic. The Internet uses a router as its traffic cop. The router determines the best path for the data packets depending on the speed and number of other traveling data packets. Internet routers regularly communicate with each other so they know what routes provide the fastest delivery. These routes are stored inside the router's memory and are called routing tables. Just as traffic patterns can vary because of the amount of traffic, construction, and road conditions, Internet patterns can also vary depending on the amount, size, and type of data being sent. This means that your data packets may not always take the same path to reach their destination. In fact, some data packets may arrive out of sequence because of delays, or they may not arrive at all. If you've ever used the internet to listen to music or watch a video that cut out or looked pixelated, you've experienced high data traffic. Eventually, your data packets will reach the destination computer's ISP. Just as highways have on and off ramps, the local ISP is the destination computer's off-ramp for your data packets. All ISPs have their own router that knows the final path to the destination computer. While these routers do interact with the internet, their purposes are to know the fastest routes to the customer's computers and provide an on and off ramp to the internet. When your data packets arrive at the destination computer, it starts the process of reassembling the packets. If the packets contain sequence numbers, the computer assembles them in the correct order and requests the retransmission of any packets that were lost during the journey. This concludes our journey of data flow over the internet. A few key points to remember are: all data is broken into smaller parts for transmission over the internet. Not all data packets take the same route between the sending and receiving computers. The application used to send the information determines if the delivery of the data packets is guaranteed. The speed at which data packets travel is affected by internet traffic.
So any questions you have, anything that we've studied so far? Because today we have concluded the first section of our prep course, that is how internet works, what is internet and web. So from next class, we would be studying the next section, that is application design, application processing, application development lifecycle, and so on. So any doubts in all the sessions that we have studied so far? Any questions? we have completed this one. What I was trying to say is this one. We have completed this one. The next one would be this, the application development life cycle and other aspects. So any doubts in these 6-7 classes that we have conducted so far? Any questions?
I do have a suggestion. If it is possible to have these slides or maybe short note of it, because it would be difficult to put all these together and make a short note of everything in order to have the, the sequences between the
Passing HTTP codes. So what are HTTP codes? HTTP codes are part of your server response. They work as a message to browser. They tells if a request can be accepted, processed or not. So what are the reasons that a request cannot be accepted? For instance, the client is not sending HTTP request, but the server is designed to receive only HTTP requests. For instance, client is sending SMTP, your mail protocol, simple mail transfer protocol, but the server is receiving only HTTPs. In that case, server will reject the request. It cannot process it. It cannot understand it. There are SMTP servers specifically designed. So we need to make sure the request that client is sending and the server is trying to understand are on same platform. So a normal HTTP status code includes 3 digits. So there are 3-digit integers where first digit defines the category of status codes. So there are total 5 categories. So the first digit defines which category this particular status code belongs to. So this belongs to informational category. So for any status code that starts with 1 is just an information from the browser. So these codes we generally do not see. They happen very fast within the process from the browser, just telling, okay, I've done this, I've done this, I've done this. We're not able to see these kind of codes. The codes starting from the integer 2 are success codes. They tell that the request has been successfully processed. Then your similarly this one for redirection 3, number 4 for client, number 5 for server error. Let's see some important HTTP status codes associated with each one of these. So number 1 is your status code 200. The one we see, the message comes is okay. It represents page you requested has been fetched, successfully done. Then another could come 301, permanent redirect. It shows that the URL has been redirected to some other URL. The web page has been moved to some new URL. Earlier, the web page was, suppose, wikipedia.com. Now they have moved to wikipedia.dev, for instance. So that is redirecting, permanently redirected. So if a user visits .com website, it would be redirected automatically to dev, and within the network, the developer tool, we would see the 301 message. Then comes 401 is unauthorized. When server receives an unauthenticated request, some requests need username and password, username and password. For example, your FTP, file transfer protocol, when these requests are made, they need username and password because file transfer protocol exchanges files over internet securely. So if a server has not received correct username and password, it would give 401 error that this is unauthorized. Someone else is trying to access it. The most common one is 404 when the page is not found. Then it could be 503 that server could not handle request due to server error. So this is server error. This is not client error. The server could not handle request. So why these requests are important? Why are we studying this? Suppose you created a website and due to some error, you're not able to see the web page on your system. Now you're trying to work over here and constantly trying to do something on your code that this becomes visible, but nothing is happening over here. Then you check the network area of the developer console. You see the error is 503.
And now if you have studied the status codes, you would know that error is not from your side. The error is from the server side. And once the server error resolves, automatically your web page would be displayed over here. So understanding these codes help us to know that if we run into some problem, is it from our side or is it from some another side? So usually the errors that we need to take care of are the errors starting from the number 4. So always remember to check what status code you're getting in case you face some errors while displaying your page on the web. I'll show you again where we saw that error message. Okay, let me pull up the Chrome for you once again. Yeah, this one. So right now, if I pull up the developer console and if I check network tab, nothing is happening. But if I reload this, just see. So these are all the status codes. Right now we are receiving everything, no issues at all, nothing, no server error, nothing, everything we are getting. And if I just pull this up, I'm getting every request, response, and different information. Just see the content type. The content type over here is HTML. The response that we received is HTML. How to check that? I think I discussed that in one of the sections. You can do is view page source. So whenever you type view page source on any web page, it shows you what type of response you have received. So just see, we have received this response. This is the response from the server. And this response is the HTML, CSS, JavaScript files, which a browser comprehends and shows us this page. So if you open some complex website, if we again go to the wikipedia.com, now just see over here, we are receiving different kinds of messages like 301 and so many other things. Your 200. If we try to mess up with this website URL, we might receive 404. Let me check if we are able to receive. If I just mess this up. Okay, just see, this document failed. They've not shown the status code over here, but this document failed. We're getting messages over here and it shows that there is a typo in your language. So instead of showing the 404 status code, the company has displayed a message over here. They have created a page which would be displayed when 404 error comes. So this is how checking status code helps us. And if I go back and I open something, now if I check the view page source, it is a very complex information that we would be receiving, but it contains everything. This is your HTML. This is your HTML part. Coming down, the script part is your JavaScript. And if we move down, you would find CSS also. Let's find it. We must be having style tag. Yeah, this is your CSS being embedded. So right now, this all feels that everything has been clubbed together. This is called minifying the information. This is done to save the space on the internet. Everything is minified and then the browser understands it, unpackages it, and then collects the information and shows everything. So these are all the links. So if you click on some link, you are being redirected to that page. So all the links that they have used are over here. If you put anything over here, you're able to redirect. So this is the source where every information is lying. This is the response that we are receiving. Everything you can check from here. And if you want to check if your if the website that you have created is mobile friendly or not, click over here. If you click over here, you have the options to change the responsiveness of your page. So if I choose iPhone SE, it would show me how the website look on that device. If I choose some Samsung Galaxy, it would show me how it would look. So you can open some other page. Suppose I open Google Images or Google Symbol, it would show me how it would look over here. And I can change to some other resolutions. It would show me how it looks. So this is used when we are trying to make websites responsive for your mobile, your desktops, and your iPads. All these things we would be studying in great detail while covering CSS. While covering HTML, we would be studying how these tags are there. If you want to inspect this particular tag, what you need to do, just click over here, and once you click over here, it would take you the HTML code. This is the HTML code over here. This is the HTML code. So if I just click over here, I would be redirected over here. Okay, let's try something if we are able to find that. Okay, let's see. So let's see if we're able to change something over here. Do we have some text over here anywhere? Okay. So right now I was trying to find if we have some text. These are all hyperlinks over here. So if I just check this particular text, yeah. So this is Google offered in. If I write something, test this page. Now just see the text changed over here. This is how we test how a web page would look, how our web page would look actually on browser. I've changed the text on Google browser, but it is very temporary. If I reload this, everything would come back. Everything would come back. Nothing changed. If I want to change again, I'll just go over here. I'll go over here. I'm getting the text over here. I'll just change this text. And if I go over here, you can see change this text. I can write my name also over here. Rahul. So my name came over here, Rahul. So why this functionality is provided? So whenever we have made something in our code and we are trying to check it on browser, we can make the changes real time, but those would be temporary, only at browser level. Our core code in our text editors or in our code editors, that would not change. So this is for that. If I, let's say, if I make large, you can see the styling is also changing. So if I make it, let's say, medium, just focus over here. Just focus over here. This one, watch now, Rahul search. I can change the text style over here right now. So why this is provided? Just to make sure we can experience how our web page would look like in real time. So if we see, okay, this one is looking good, I would make these changes in my code editors. So that's how we target, that's how we debug, that's how we find how a web page would look, how to make responsive, how to see on different devices, and so on. So this is just a brief introduction of Chrome developer tools. We would be using them in great detail and everything would be explained. So like this is the box model. We would be studying that, what this actually is. What does this mean?
Yeah.
So
Thank
we
you,
would be
Rahul.
studying that. Yeah.
Yeah, it was, I mean, we currently, most of us don't know the value of what we are looking at while Rahul is explaining, but at least, I mean, at this particular moment when Rahul shows us these, it comes to our mind that there is something. And later on, this small signal will help us understand things better when we go in depth into it. So thank you very much, Rahul.
You're welcome, Talash. Thank you so much.
Yeah, so I think we are done with our day. Let's wrap it up. If there is no question, then I will share the recordings for yesterday and today in a while. I'll have my dinner and then I'll share it.
And Talash, I'm sharing the video link with you. So
okay, I'll just copy it. So yeah,
yeah,
that's important for me in terms of my job as well. Thank you very much.
You're welcome. And thank you so much, everyone, for joining in. And we'll meet tomorrow at same time, and we'll start with a new topic.